Hello viewers, today we are going to study about refraction in prism. This is again a very interesting topic. So let us see first what is a prism. See, how many surfaces it is having? It is having 5 surfaces. You can see here 1, 2, 3, 4 and 5. See, these two are the plane surfaces. This is the base of the prism and these two are the triangular surface. So these two plane surface are the refracting surface and they are forming an angle in between, and this is called the angle of prism. So we will see that if a ray is incident on one of the plane surface of the prism, then after refraction on the first surface, that is from rarer to denser, because here the light will travel on the rarer medium, that is air, and then it will enter the glass, that is the denser medium. First refraction will happen over here. Then the second refraction will happen when it will travel from denser to rarer, that is from glass to air. So second refraction, after doing the second refraction, it will come to the air. So what is happening? The ray is getting deviated from its path. We will see that by how much it is deviating, and we will see that the deviation is towards the base of the prism. So let us now see how the angle of deviation is related with the refractive index and the angle of the prism. So let us now see the diagram and the relation between these. I hope you will like the lecture. So please concentrate on the lecture. Let us draw the prism first. So here the prism is drawn. So this is A, B and C. BC is the base of the prism. Base. And which I told you, AB and AC, these are the refracting phase, or you can say the plane phase where the refraction takes place. Now let us draw the incident line or the ray. This is the incident ray. So here this is the rarer medium, which is air, and this is the denser medium, which is your glass. This one is your denser medium. So what will happen? Refraction will happen and it will go from, it is coming from rarer medium and it is entering the denser medium. So it will go towards or away the normal. It will move towards the normal. So let us draw the ray over here. It will bend towards the normal. So first let us draw the normal. This is the normal. Let me name the normal N1. Fine. This is the ray. First refraction has happened. Now what about the second refraction? See, this is again your denser medium and this is your rarer medium. This is your denser medium. So the second refraction will happen here. Let us draw the second normal now. This is the second normal, N2. So the ray is deviating away the normal. It is deviating away the normal. Fine. In this manner. Okay, is it clear? Now, let us name this point where these two normal meet. Let us name this O. So I hope the diagram is clear. Now, if the incident ray would not have bent, then it would have gone straight. That means it would have gone like this. Let me name this K. Let it be K. Let it has gone till the point K. It would have extended till K. Now, if it has shown refraction, that means it has deviated from its path. Now, how it has deviated, we will be seeing this. Now, the second refraction has happened in the surface AC. So, how it is being deviated, you will see here. Now, this ray, the second ray, if it would have not been deviated, let us extend this also. So, on extending this backward, see this ray, I am extending it in this manner. So, the angle of deviation, we can draw the angle of deviation here. This is the angle of deviation delta. This is the angle of deviation. Now we have to correlate this angle of deviation, how it is related with this angle of prism and how it is related with this angle of incidence, how it is related with angle of emergence, how it is related with angle of first refraction, second refraction, because of course it is showing deviation, but how much deviation? All these things we will be seeing now. So I hope the diagram is very, very much clear to you all. Again, I'm explaining you. This is the incident ray, this one. Let me name this. Let the point of incidence, this point be P. Let the ray be incident at point P. Now, if it has shown the refraction at this point, then it shows the bending, first bending. Fine, it goes towards the normal, and then it has the second refraction at the surface AC. Let us name this point as R. Now, it shows the second refraction here. Now, if I extend the point, if I extend the incident ray till K, and if I extend the final refracted ray here backward, then it would meet at a point, let us name this T. So this angle is called angle of deviation. By this much, the angle of incidence, by this much, the incident ray has deviated from its path. Now let us come to the derivation. So from the figure, first we see that angle I, angle I will be equal to how much? Angle TPO. And your angle E will be equal to how much? Angle TRO. Fine. From geometry, we can see this. Now, also, angle TP, you see here. Angle TPR. What will be angle TPR? Angle TPR will be equal to angle TPO minus R1. Now, what is angle TPO? Angle TPO will be equal to angle I minus R1. So angle TPR is angle I minus R1. Similarly, angle TRP will be equal to angle E minus R2. So we are getting here two equations. One is angle TPR is equal to angle I minus R1, and second is angle TRP is equal to angle E minus R2. Now, what we will do here, angle, we have to put these values. So in this triangle, triangle POR, we see here, we can use the next page here, that R1 plus R2 plus angle O, all these angles will sum equal to 180 degree. Also, we see that in this quadrilateral APOR, you see in this quadrilateral, angle P, I'm writing it over here, angle P plus angle R, this will be equal to how much? 180 degree, because we are drawing the two normal N1 and N2. So this two will be 90 degree. So naturally angle A plus angle O will be also equal to 90 degrees. So I'm writing here angle A plus angle O will be equal to 180 degree. So from these two equations, what we get, that angle R1 plus angle R2 will be equal to angle A. So put this equation number 3. Put this equation number 3. 1 minute. Yes, equation number 3. We get a very important relation over here. So now from this figure, you can see this is the external angle delta. So this will be equal to the sum of these two internal angle. Angle TPR plus angle TRP. So I'm writing this. External angle delta is equal to angle TPR plus angle TRP. Now what is this? TPR. Just now we have done this angle I minus R1. So we are writing this angle I minus R1 plus angle E minus R2. Okay. Now we have to put this value. So for this, we know that from Snell's law, refractive index is equal to sine I upon sine R1. From the figure, you can see from figure, sine I upon sine R1. Now, because angle is very, very small, so we get here, we can write I upon R. So what we are getting here, R1, sorry, I is equal to N R1. Similarly, N is equal to sine E upon sine R2. So we get here E upon R2. So we get E is equal to N R2. Now put the values in equation number 4. So on putting the values, what do we get? Delta is equal to how much? I. I means N R1. See, minus R1. Minus R1. After that, plus NR2 minus R2. So how much are we getting here? NR1 plus NR2 minus R1 plus R2. So we can write this NR1 plus R2 minus R1 plus R2. Now what is this R1 plus R2? This is your angle of prism. This we have already done. So delta That means deviation is equal to NA minus A. That means delta deviation is equal to N. Yes, we can take here A as common. What happened? Yes, we can take delta A as common and N minus 1. So this is the relation between deviation, by how much the incident ray has deviated, angle of prism, and the refractive index. More the angle of prism, more will be the deviation. More the refractive index, more will be the deviation. I hope it's clear. Now, from the figure you can see, we have done all the derivations here. From again, I am telling you, more the refractive index, more will be the deviation, this deviation. And more the angle of prism, more will be the deviation. Now, what about angle of eye? How does it depend upon eye? That also we should know. We have to set a value of I for setting up the angle of deviation. So we'll see here we have derived here on page number 2. Here you can see here delta is equal to I minus R1 plus E minus R2. From here only you can do this. I'm writing here delta is equal to I plus E minus R1 plus R2. Now R1 plus R2 is what? A. So delta is equal to I plus E minus A. Fine. Here we are getting again a relationship. You can see here. That means it depends upon your I. We have to set a value of angle of incidence for getting the angle of deviation. Now, if we plot a graph, I'm plotting a graph, you see how does it depend? Just you see here. If we plot a graph here, see what happens if this is your angle of incidence and this is your deviation. If angle of incidence increases, then what happens? This deviation starts decreasing. And for a particular value of angle of incidence, this angle of deviation becomes minimum. Now, for when it becomes minimum, for only a particular value of I, and that value at this value, I is equal to E. That means I is equal to angle of emergence. And for that value, this delta is called delta M. That is angle of minimum deviation. Angle of minimum deviation. At this, what happens? I is equal to E. This is only one value, one particular value. For only one particular value, this happens. Fine. Now, what is the refractive index? I mean to say, we are going to find what is the value of prism. We say that prism relation. Nu is equal to, or n is equal to, someone says it denoted by nu, someone denoted by n. Both are equally right. So that is called prism relation. What is that? See, nu n equals to what? Sine I by sine r. Okay. So now, in this case, if we are telling this that what happens for minimum deviation? In this case, for minimum deviation, R1 is equal to R2 and this is equal to R. So what will happen? R1 plus R2 is equal to A. We know this. So here in this case, what will happen? 2R is equal to A That means R is equal to A by 2. We are getting this. Now we are also knowing, just now we have done here, you can see I plus E minus A is equal to delta. So we will do this I plus E minus delta is equal to A. That means here, in this case, I told you that I is equal to E. That means 2I, fine, is equal to how much? We can write this 2I is equal to A plus delta. We are getting this. Or I is equal to A plus delta upon 2. So what will be the value for refractive index? We will write here n equals to sine I upon sine R. So n equals to sine I. What is your I? I am getting A plus delta, A plus delta, of course delta M, because this is your minimum deviation, and R. R means, see, we have done here A upon 2. A upon 2. So this is the prism formula we say. Okay, this is your refractive index, and this is the case for minimum deviation, this one. Okay, now children, I hope it's very, very much clear to you. This was very easy also. I hope there is no problem here. Now, as in every class, I tell you, see, again, I am concluding it. This was the prism. This was the two refracting surfaces. This was your angular prism. And finally, we got the deviation of the incident ray, and we show that we have means derived that how the deviation is dependent on the angle of prism and refractive index. And we also studied about what is angle of minimum deviation. So now some of the questions we will be doing, I'm giving you a worksheet which you will be solving, and then you will be if there is any problem, you will be writing in the comment section. Answers also you can upload over there. And if there is any question, you can of course ask. So now I'm just showing you the questions. Just a while. Because once you do the questions, then always your concepts are clear. See, here it is in the first question, it is asked, what is the minimum deviation? Angle of refraction is given. Angle of incidence is given. Second question also, angle of incidence is equal to angle of emergence, and the latter is equal to 3/4 of angle of prism. So what is the angle of deviation? Third, a thin prism of 5-degree angle gives a deviation of 3.2 degree. What is the value of refractive index of the material of the prism? All are direct formula based. Fourth, a ray of light incident at an angle theta on a refracting face of prism emerges from the other face normally, means perpendicularly. If the angle of prism is 5 degree and the prism is made of material of refractive index 1.5, what is the angle of incidence? Now in your term 2, of course, subjective type questions will come, but this you have to practice for your concept to be clear. Now question 5, and of course your competitive exams are there. Question 5, how does the angle of minimum deviation of glass prism vary if the incident violet light is replaced by red light? It depends upon, of course, how it depends upon wavelength, refractive index. This I am giving you the hint and you will write the reason. What is the sixth question? What is the relation between the angle of prism, angle of minimum deviation, and refractive index of the material of the prism? For seventh question, plot a graph to show the variation of angle of deviation as a function of angle of incidence for light passing through a prism derive an expression for the refractive index of the prism in terms of angle of minimum deviation and angle of prism, which we did in the last section of the class. So now you finish all this as a revision, and during the revision class, we will be doing more and more questions. So children, I hope from the lecture, it must be clear to you all. So revise the whole concept, and we will meet in the next class. Okay, thank you all.